Yeah, two tabs A and B fills a crescent in 42 and 56 minutes respectively. If both the tabs are open together, then find the time taken to fill the crescent. So how do we do it? So in this case, what happens is like whenever there is a crescent, so we try to take this as crescent. So crescent is nothing but a small tank. So in that case, one pipe A alone fills the tank means it takes 42 minutes to fill it. And the other tap tries to fill it means so it will take 56 minutes. And if both the tabs are opened together, then find the time taken to fill it. That is what they have mentioned asked. So in this, we can solve the same problem through LCM and fraction method. And as we have seen, as I have said, LCM will be the easiest one when we are going for tougher problems. So we'll be going with LCM method. So we try to take the total capacity here by assuming an value, and we are not just assuming any random values. We are going to take LCM for this numbers, which is like 42 and 56. Yeah, and if you try to take LCM for these two numbers 42 and 56, you'll be getting it as, yes guys, so you'll be getting it as 168. So we try to assume this 168 liters as the total capacity of this uh, tank, and rate at which tap A fills the crescent is, so as we have seen, so rate of filling the crescent is given by total capacity 168 divided by time taken by pipe A to fill the crescent. So it is like 42. So we can say it as 4 liters per minute, and 168 divided by 56, so it is like 3 liters per minute by B pipe. Yeah, and my question is, if both the pipes are together, so in how much time will they fill the crescent? That is our question. So if both the pipes are together, so total time taken is given by total work in the previous case, but here it will be converted as total capacity divided by work done, or rate of filling here, rate of filling per minute or hour. Yeah, so in this case, if both the tabs are kept open, A and B are together filling the crescent, so then how much liters will be filled in a minute? So So first pipe will be like 4 liters per minute, and second pipe will be 3 liters per minute. And if you add it, it is going to be like 7 liters per minute. And in that case, time taken to fill the crescent is given by same 168 is my total capacity. Out of rate of filling the crescent is 7 liters per minute. So it is going to be like 24 minutes. So if both the pipes are kept open, it will be filling in 24 minutes. Yeah. Hope you guys are getting this. And moving on for the next problem. Uh, I'll give you a minute to read it and understand it, and then I'll try to solve this problem, guys. Yes, guys, what they're saying here. Two taps are there, A and B, can fill a crescent in 10 minutes and 15 minutes respectively. Both the taps are opened together, but at the end of 3 minutes, tab B is turned off. So, in how much time will the crescent be filled? So, as we have done in the earlier case, I don't know the total capacity of the tank. So, what we do, we try to take LCM, which is an assumed value for these numbers 10 and 15. So, we'll get an LCM of 30. So, 30 liters is the total capacity of the tank we assume. And rate at which tap A fills the crescent is, so A pipe fills the crescent in 10 minutes. So it is like 30 divided by 10. You'll be getting it as 3 liters per minute. And tap B fills the crescent in 15 minutes. So it is like 30 liters divided by 15. You will be saying it as getting the rate of filling the tank is 2 liters per minute. And if both the pipes are kept open, so rate at which A pipe and B pipe together fills the crescent is 3 liters plus 2 liters. So it is nothing but 5 liters per minute. But what they were saying is total capacity of the tank is 30 liters. So A pipe and B pipe are kept open at the beginning, but at the end of 3 minutes, tab B is turned off. So end of 3 minutes means, so after 3 minutes, what happens? So B pipe is turned off means, so A pipe is running. So in that case, can we say that these two pipes have been opened for 3 minutes, especially? Yeah. So if these two pipes are kept open for 3 minutes, how much liter would have been filled in the tank? So both the pipes are kept open. It will be like 5 liters in a minute. So into 3 minutes, so it would have filled how many liters? 15 liters. So to totally fill this tank, it should be like 30 liters. That is the total capacity of the tank. And in that case, remaining has to be filled by whom? So it is by A alone. And that capacity is like 15 liters. And they have asked for in how much time will the christen be filled. So to answer that, if pipe A alone is kept open, it will fill 3 liters per minute. And in how much time they have asked? So answer is into 5 minutes will give me 15 liters. So answer for this is 3 into sorry 5 into 3 minutes will give me a value as 15 liters, and unfilled portion will be like 15 liters, and the time taken to fill the remaining crescent. So time taken, as we have already mentioned, so time taken is given by so in the previous case it will be like total capacity, but here it is like remaining capacity out of rate per minute. So in that case it is like 15 divided by 3, and you will get it as 5 minutes. Yeah, so that will be your answer. So that is how you'll be calculating this. And moving on for the next problem. So next is also pipes and crescents, and this is also going to be very easy. So try to solve it in LCM method. I'll give you a minute to understand the problem. Try to read it and understand it, guys. Yes, guys. So what they're saying here, a crescent is fitted with three tabs, namely P, Q, and R, and P and Q can fill the crescent in 10 and 15 minutes respectively, where R empties emptying tap fitted at the bottom of the crescent can empty it in 12 minutes. If all the three pipes are kept open, in how much time will the crescent be filled? So, for example, I try to draw it here. So, I try to take this as the P pipe, and this can fill the crescent in 10 minutes. And this, I try to write it as Q pipe, and this can fill it in 15 minutes. And there is a last pipe which is R pipe at the bottom of this, and this can empty the crescent in 12 minutes. If all the three pipes are kept open, only they have asked. So first, we don't know the total capacity of the tank, so we try to take, or we try to assume the capacity of the tank by taking the LCM for all these three values: 10 minutes, 15 minutes, and 12 minutes. If we go for that, you will be getting it as 60 as the LCM. So we try to assume the total capacity of the tank as 60 liters, and the rate at which P pipe fills the crescent. So in that case, 60 divided by 10 minutes will give you a value as 6 liters per minute, and rate at which Q fills the crescent. So Q, it is like 60 liters divided by 15 minutes. So it is nothing but 4 liters per minute. Rate at which tap R empties the crescent. So empties the crescent also. So in that case, a full tank is being emptied. That means total capacity is getting emptied. So there also it is like nothing but same 60 liters and divided by 12 minutes. So it will be giving you the emptying time as 5 minutes. But since it is emptying, while we are writing it, we try to mention it with a minus mark for our understanding. So minus 5 liters per minute. Yeah. So the rate at which P, Q, and R fills the crescent. So what happens is like P pipe tries to fill the crescent with 6 liters per minute, and Q pipe tries to fill the crescent with 4 liters per minute, and R pipe tries to empty the crescent in 5 liters per minute. So the first two pipes will be filling the crescent, and the third pipe will be emptying the crescent. That means only 5 liter will be filled in a minute if all the three pipes are kept open. And they have asked for the time taken to fill the crescent. So time taken is given by, once again, a total capacity out of rate at which it is filling per minute or per hour, depends on the timing question. So in this case, it is like 60 is the total capacity, and if three pipes are kept open, it is like divided by 5, and you'll be like 12 minutes. So answer is 12 minutes. So in 12 minutes, if all the three pipes are kept open, it will be filling the crescent. Yeah, hope you guys are getting this. And moving on for the next problem. Try to read the question, understand it, and I'll give you a minute to do that. After that, I'll be explaining it. So if you see the alone, so we don't know the total capacity of it. So once again, so before getting into the total capacity, for example, what they're saying it, first we try to understand it. So the rate at which the tap fills the crescent is, we don't know. So before that, yeah. So I try to assume it as like pipe A, time taken by pipe A to fill the crescent is usually 20 minutes. And if there is a leak, so leak will be always doing a negative work. So in that case, a pipe A and a leak is there. But what they were saying is that it took 10 extra minutes, not totally 10 minutes, it took 10 extra minutes. So generally, a pipe alone can fill it in 20 minutes, means it took 10 extra minutes, so it is going to be like 30 minutes. And they were asking, find the time in which a leak alone can empty the crescent. So this timing they have asked. And here, filling per minute, try to write it. And what we do is like whenever we are trying to take LCM and assuming the capacity of the tank, so we'll be taking between these two values 20 minutes and this 10 minutes. Sorry, 30 minutes we will be taking. So LCM value is going to be somewhat like 60 minutes. So that is the assumed Yes, guys. So the rate at which the time taken to empty the full crescent is like 60 liters is the total capacity divided by 1. So it is like 60 divided by 1. So it is like 60 minutes. Hope you guys are getting this. And moving on for the next one, work equivalence. So what does this work equivalence means? Yes, guys, what does this work equivalence means? Yeah, generally what happens is like, for example, if I'm trying to construct a building here, so this building is being constructed by 5 men in 2 days. Yeah, and I want to construct similarly another building over here, but I need to complete that building in 5 days. So, how many men are required on each day? Yeah. So, in this case, 5 men into 2 days. So, can we assume that for each day, 5 men are coming? So, for 2 days, there would have been like 10 men's work would have been completed here. So, to construct the similar building, here also I need 10 men's work. So, in such case, if 5 days are there, so into what will give me 10? So it is like nothing but 2. But 2 men's per day will be giving me 10 men's work, right? So in this case, if work is equivalent, it is nothing but number of men's on the left hand side into number of days on the first set, and number of men's on the second set, and number of days on the second set, and this will be equal on both the sides. Yeah, if work is equivalent on both the sides. For example, they were saying the same thing. So 5 men can do the work in 2 days for this building, but I need to construct three similar buildings. I want to construct three similar buildings. For all these three buildings, so I want to complete this buildings to be done in for all these three buildings. I want to complete this in 5 days. So in how many men's are required to do the work? Yeah, hope you guys are getting it. So for building one building, 5 men can do the work for 2 hours, 2 days. Then the work is done. The other case, I need to build three similar buildings, and I want to complete the work in 5 days. So how many men are required to do the job? So in the previous case, the work done was equivalent. So same amount of work, so no issues. Whenever there is different amount of work, then it will be like this: number of men in the first set into number of days in the first set divided by work done when work done in the first set, and number of men in the second set and number of days in the second set divided by number of amount of work to be done in the second set. If you divide it, then both the values are going to be same. So for similarly constructing three such buildings, we need 30 men's total work. For one building, it is like 10 men's means three buildings, it is like 30 men's work. So in that case, what into 5 will give you 30 men's? So it is like 6 into 5 will give me 30 men's work. Yeah. So answer is 6 months are needed on each day to construct the three buildings in 5 days. So if you check it here, so 5 months into 2 days for one building. So work done is one part. And in the other case, we don't know the number of months, so we try to keep it as x into number of days we need is 5 days and divided by 3. And if you just try to cross multiply it, you will get the value of x as 6 days. Sorry, 6 months. Yeah, hope you guys are getting this. So whenever the work is same, then no issues. So M1 into D1 will be equal to M2 into D2. And in the second set, when the work is different, so M1 into D1 divided by W1 will be always equal to M2 into D2 divided by W2. Work done, amount of work to be done should be divided. In that case, then only both the values will be equivalent. So this is called as work equivalence. So guys, actually, what happens in real time is the work done by a man and the other man will be different. But in this case, what we do is like we try to assume a value like this. So the number of men's, the amount of work each man doing is equal on every day, and we try to calculate the values here. Yeah, and moving on for the first problem. So in this case, sometimes they will be giving it as men's days and so Yeah, moving on for the next question. So this is also a similar problem. Please try to do it, and I'll give you a minute to understand the problem. So after that, I'll be solving it. Yes, guys. Moving on for the next problem. So what they were saying is like 30 workers can make 24 tables in 21 days, working 8 hours a day. So if 35 workers want to make 18 such tables in 12 days, how many hours should they work every day? So in the first case, workers are like 30, and number of days is like 21, and the number of hours is like 8 hours, and they can make 24 tables. And in the second case, it is like 35 workers, and we they mention like 12 days, and the number of hours we have to calculate it, and number of tables to be made is 18. So how do we do it? So in this, men's days and work is okay, but what about these tables? So that table is the work to be done over there. Yeah. So moving on for this. So work done per day. Sorry, a number of workers in the first case is like 30 into number of days is 21 into number of hours is 8, and in the second case number of work is like 35 into number of days is like 12 into number of hours is like, we try to keep it as x, and in the first case it is like 24 tables, so divided by 24. In the second case it is like 18 tables, so it is like divided by 18. So that if we try to calculate it, you'll get it. So it will be like x value is nothing but 9 hours per day. So that will be your answer for this one, guys. So whenever the work is different, then your answer will be then the formula will be like number of m1 into d1 into h1 divided by w1 is equal to m2 into h2 d2 into h2 divided by w2. Yeah, hope you guys are getting this. And moving on for the next problem. So this is also a similar problem. I'll give you a minute to understand it. Please try to do it fast. This guy's answer for this. So what they're saying is like nine friends can eat nine ice creams in 9 minutes. How long will 15 friends take to eat 15 such ice creams? So when this number of friends is that nine ice cream is also nine. So in the second case, it is like 15 friends are there and 15 ice creams. So what are the time taken? So most of you will be thinking like, yeah, so nine friends, nine ice cream, it is going to be like 9 minutes means 15 friends or 15 Yeah, sorry for the technical error. So I don't know why. Because of some technical issues, it's been getting delayed or like discontinuous a few times. So yeah, so in this case, nine friends, nine ice creams. So it is like 9 minutes. So one friend will have one ice cream at a time, and he will complete that one ice cream in 9 minutes. And similarly, if 15 friends are having 15 ice creams, so there also it will be like same 9 minutes will be the timing here. And I hope you guys are getting this. And moving on for the next one. Yeah, try to answer this one fast in the chats, guys. And this problem is also similar, but you have to understand the problem, and then only you can able to answer this one. Yes, guys, what they're saying here. Ms has provision for 360 men's for 70 days. If the number of men's increase by 90, so for how many days will the provision last? So initially for 360 men's, so the number of days for the provision is like 70 days. So if 90 men's were increased, so be clear, guys, they were not saying totally 90 men's. So they were saying that 90 men's were increased. In that case, 360 plus 90, it is going to be somewhat like 450. So totally 450 men's can do or can complete that provision in how many days? So that is the question now changed here. Yeah, how do we do it? So number of men's in the first case is like 360 and number of days is nothing but 70. In the second case, it is like 450 men and into how many days we try to keep it as 6, and on the both the s sides the provision is equal or the work to be done is also equal. So that is how we'll be taking. So it is only based on number of men and days, and if you try to solve it, so you will get the value of that x as 56 days. So that will be your answer for this one. So if 90 months extra comes, the provision will be lasting only for 56 days. So that is going to be your answer for this one, guys. And moving on for the next one. Yeah, try to read this, understand it, and then I'll be explaining how to do it. can do a piece of work in 10 days, while 13 boys and 24 girls can do the same work in 8 days. Find the time taken by 15 boys and 20 girls to do the same work. Guys, in such kind of questions, what we are going to do is, so we try to convert the total values, or like here they have only given boys and girls. So either try to convert everything in terms of boys or everything in terms of girls and then try to calculate it. Before converting boys into girls, you should know, so how many boys are equivalent to how many girls, or how many girls are equivalent to how many boys. Then only you can able to convert it. Yeah. So what I try to do is, based on the given content. So first case, it is like 12 boys and 16 girls, and they're saying that they are working for 10 days. So 12 boys into 10 days, so it is like 120 boys, boy days we say, and this 16 girls for 10 days, it is going to be like 160 girl days. And this in the other case, if you go for, so in the second case, 13 boys and 24 girls can do the same work in 8 days. So 13 boys means 13 boys into 8 days. So which is like 104 boys, boy days. And in the other case, it is like 24 girls into 8 days. So 192 girl days. So in such scenarios, we can say that 120 boys plus 160 girls work, which is in the first case, is equivalent to 104 boys plus 192 girls work in the second case, because they were trying to do the same amount of work. So after that, we try to bring all the boys on one side and all the girls on one side. So when this comes on the opposite side, the sign will be changed. So in that case, we can say it as 120 minus 104. It is going to give me 16 boys. And 192 minus 160, it is going to give me 32 girls. And if I try to solve it, I'll get it as one boy equivalent to two girls. So, as I have mentioned already, so we need to know how many boys are equivalent to how many girls. That just now we calculated it as one boy is equal to two girls. After that, they were asking for how much time will this 15 boys and this 20 girls will take to do the same work. Yeah. So we know that in the first case, it is like 120 boys plus 160 girls in this third case, So it is like 20 girls in, but because they were trying to do the same amount of work. So in that such cases, what we do is like we try to convert everything in terms of boys or everything in terms of girls using this equation. One boy is equal to two girl. So if I try to convert it, so 160 girls are here. So two girls is equal to one boy means it is going to be like 80 boys, 80 more boys. Already 120 boys are there. So it is like 200 boys is equal to here. So 20 means it will be like 10 boys. So totally it is like 25 boys into X number of days. So if you try to cross multiply with this X value, you will be getting it as 8 days. So that will be your answer. Yeah. So if 15 boys and 20 girls try to do the same work, they will be completing the work in 8 days. So from the given piece of details, we'll try to calculate how many boys are equal to how many girls, and then with the given piece of detail and comparing it with what we need. So we try to convert everything in terms of boys or girls, and if you try to calculate the number of days, you will be getting it as 8 days. So that is how we will be calculating for this. And moving on for the next one. So this is where we're done with all the problems based on time and work. So I'll be moving on for probability content. So on that day, we would have done with permutations and combinations. So in today, we'll be seeing about probability. So what is probability? Yeah, what is probability, guys? So probability is nothing but the chance of getting an event to be happen, or getting that thing to be, what is the possibility of getting that thing is called as probability. Yeah. So how do we calculate probability? For example, I'm tossing a coin. So what are the outcomes it can come? So outcomes can be a head or a tail. Yeah. So there are two outcomes. So whatever may be the total outcomes, so all that outcomes are said to be as sample space. So all the total outcomes possible is called as sample space value. And after that, sample space. So whenever we are trying to toss a coin, we will be asking for something, right? For example, I want a head. What is the probability of getting that head? So probability of favorable event, whatever we are asking is called as favorable event. Yeah. So that is given by P of E. So where favorable event will be in the numerator value. What is the chance of getting that favorable event? Out of the sample space value. So sample space value is nothing but 2 in the denominator, and the favorable event is out of head and a tail. So getting a head is called as the favorable event. So it is one chance. So value is nothing but 1 by 2. And whenever we ask for a head, it can be a head, but sometimes the things we say it as unfavorable can also happen to us. So, what is the possibility of getting that unfavorable event to be happening here? So, P of E bar represents the unfavorable event, and that is given by unfavorable event out of sample space value. So in that case, unfavorable event is like, so I ask for a head. So if I get a tail, and that is called as unfavorable event. So the chance is one out of the two chances possible. Yeah. And last thing is, whenever you try to add a favorable event probability and unfavorable event probability, it will be always going to be 1, because favorable event is head and unfavorable event is tail. So obviously it will end up in all the two possible answers. So 2 by 2 is going to be nothing but 1. So whenever a probability of favorable plus probability of unfavorable is being added, so you'll be getting the value as 1. And moving on for the questions. Yeah. Try to read the question, then I'll be answering this one. I'll give you a minute to read it. Yes, guys. So in this case, what they're saying is like, if you are trying to toss 4 coins at a time, so how many different outcomes are possible? So whenever we are trying to come up with the different outcomes, so for tossing one coin, the possibility of getting two outcomes. So for the second coin also the possibility of getting two outcomes, and third coin also you'll be having a possibility of getting two outcomes, and fourth also you'll be having possibility of getting two outcomes. So in such cases, what we can do is like, so there is going to be like combinations. So that is like first head combined with the second tail and the third head and fourth tail. So there can be any combination can occur. So in such cases, we'll be getting different outcomes. So between these values, we try to multiply. So you'll be getting the number of outcomes as 16. So total number of possible outcomes is going to be 16. Yeah. So number of outcomes per coin is 2, and total number of outcomes for 4 tosses is going to be 16. So this also can be written as, whenever it is number of coins, so it is nothing but 2 power n, where n represents the number of coins. So it is like nothing but 2 power 4. So once again I'll get it as 16 here. So, if 4 coins are tossed at once, will the number of outcomes be same? Yes, it will be. And moving on to the next one, if a dice is rolled 3 times, how many different outcomes are possible? So, you guys know a dice. So, whenever we are trying to roll a dice, so the outcome sample space value is going to be like 1, 2, 3, 4, 5, and 6. So 6 are the possible outcomes of it. So if a dice is rolled 3 times, so how many different outcomes are possible? So number of outcomes per dice roll is like 6, and for total number of outcomes of rolling a dice is given by 6 power n, where n is the number of dices rolled, or number of dices or roll. So in that case here it is like 6 power 3. So it is going to be nothing but 216 as your answer. Yeah. So 216 possible outcomes are possible in a dice. And moving on for the next one. If two cards are drawn at random from a pack of cards, how many different outcomes are possible? So before getting into the cards, I want you to say, so how many cards in a pack? So there will be like totally 52 cards in a pack, and in that we try to split it as two. So based on the colors, one is like red and black. So red is like 26 cards inside it, and black will be like 26 cards. And in this, based on the design they have, it will be split down into two. So red will be having two shapes. One is like hearten, and other is like diamond. And black, you'll be having two shapes. One is paid and the other is clever. Yeah. So in case of cards, the numbering will not be from, so in each of this shape you will be having 13 cards. So that 13 cards number will not start from 1 to 13. So it will be starting always from A. So A is nothing but 1. And number starts from 2 till 10. And after 10, you'll be having it as J, Q, and K. So, what is this J? J for Jack, not Joker, and Q for Queen, and K for King, and A represents Ace. So, all this four will be having same numbers A to 10, 2 to 10, and then J, Q, K. Fine. So, first one, if two cards are drawn at random from a pack of cards, how many different outcomes are possible? So, first case is like with replacement. So, I am trying to take the first card. So, out of 52 cards, I have to take the first card means. So, 52C1 is the possibility here. And when I am going for the second card, so with replacement, they particularly mention with replacement means if a card once taken will be kept inside it once again. So in that case, when I'm going for the second round, also I'll be having like 52 cards. So from that, I have to select one. So selection can done in combination. So it is like 52 C1 there also. Between this, there are multiple possibilities or multiple combinations can happen. So value is like we try to multiply between these two. And without repetition means at a single touch itself we are going to take it without replacing the card. So we can do it as 52 C2. So that will be the value of it with replacement and without replacement. Hope you are getting the difference. And moving on for the problems based on probability. So try to read the question and understand it, and I'll give you a minute to do that. Yes, guys. So the probability problems on probability. So if two letters are selected at random from English alphabet, what is the probability that both of them are vowels? So So our first probability is given by favorable event by sample space. So what is the way of selecting two alphabets from English alphabets? So out of 26 alphabets, you have to select two alphabets. So selection of two alphabets is done through combinations. So 26 C2 and in the numerator, the number of ways of selecting two alphabets such that both of them are alphabets they have vowels they have mentioned. So how do we get vowels? So out of five vowels, so what is the possibility of getting that two vowels? So it is like 5C2 divided by 26C2, and this will give you the answer for it. Yeah. And moving on for the next question, at least one of them being a vowel. So probability is like once again favorable event out of sample space value. So s- prob sample space value is nothing but 26C2 as we have seen already. Any two vowels, sorry, any two alphabets from all this alphabets, and at least one of them is a vowel. What is this? At least one of them. So minimum possibility of being one vowel. So one can be vowel and other can be a consonant, or else both of them can be vowels. So in such case, 5C2 is the possibility of this one, and here. So one vowel means 5C1 out of five vowels taking one vowel, and in the other case, it is like 21 consonants will be there out of that taking one. So between this, they were trying to combine and give you a value. So it is like multiplication will be happening here. So either one vowel, one consonant possibility, possible arrangement can be done, or else both of them being vowel. So or condition is used means we'll be adding in between that value. So 5C1 into 21C1 plus 5C2 divided by 26C2. So that is going to be your answer for this one. And moving on for the next one, try to answer this one fast, guys. It's quite easy and simple problem. Yes, guys, what do you think here? If three coins are tossed simultaneously, what is the probability that exactly two of them will show tails? So if three coins, so probability once again it is nothing but favorable event out of sample space value. So if I am trying to throw three coins, what is the sample space value? So I have already mentioned you guys, so whenever it is coins, sample space value is given by 2 power n, where n is the number of coins, so it is nothing but 2 power 3. So value is like 8. And a favorable event, so favorable event is nothing but exactly 2 shows tail. So in that case, head tail tail is a possibility, and tail head tail is another possibility, and tail tail head is another possibility. So three possible ways are there. So the probability is nothing but 3 by 8. So answer for this one is 3 by 8. And moving on for the next one, try to answer this one, guys. It's quite easy and simple. Yes, guys. If four coins are tossed simultaneously, what is the probability of getting two or more tails? So once again, probability is nothing but favorable event out of sample space value. So sample space is nothing but whenever we are trying to toss four coins, so it is given by 2 power 4, and favorable event. So favorable event is something like getting two or more tails. So two or more tails means, so what's the chances of getting two tails? So two tails out of four, so it is like two tails, and other two as heads is a possibility. And another case is they said more than two tails, so three tails and one head possibility is there, or else all the four being tails is also possible. Yeah. So what we can do is like, so instead of going for these three possibilities, we can go on the unfavorable event, and based on the unfavorable event also we can try it. So what is unfavorable event? So if they say it as two or more tails, getting less than two tails is unfavorable event. Less than two tails means zero tails and one tail. So zero tail is all being head, only one chance. And other cases, one tail. So head, 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 tail, and a head, head, tail, head, head, tail, head, head. tail, head. So totally how many chances? Five chances out of, so unfavorable event, so is represented by P of E bar. So unfavorable event divided by sample space value. So it is like 5 by 2 power 4. Once again, it is going to be like 16. So from the unfavorable event, how will you go for this favorable event? We know that favorable event plus unfavorable event is going to be some value of 1. So in that case, if this unfavorable event goes on the other side, so P of E is 1 minus 5 by 16. So it is going to be like 11 by 16. So value is favorable event is 11 by 16. So here the value is 11. And even if we go in this way of trying two heads, two tails, three tails, and four tails. So there also you'll be getting the value as same 11 by 16. Yeah, sometimes you can go for certain problems with a favorable event directly, and if the your favorable event is huge, then you can go like unfavorable event first, and based on that you can able to calculate the favorable event. So that's it, guys. So that's it for the day, and hopefully you would have done very much with the aptitude parts, and we would have covered important topics on quantitative aptitude. In the upcoming sessions we'll be viewing what all the other aptitude questions and what all the aptitude topics they'll be coming up with. Thank you, guys. Have a great day.